Welcome back to the System Design series. In the previous video, we learned about the 8 different activities that make up the system design methodology. In this video, we will focus on the very first activity, that is identification of the design goals. After you watch this video, you should be able to identify the design goals for a system and get going with your system design. We did cover the concept of system design goals in an earlier video. If you have not seen that video, please go and watch that video if you want to understand in detail what design goals are and why they are important. Let's briefly recap what design goals are before we go further. The system design goals are the qualities of system that we want to optimize. In other words, these are the properties and the behaviors that we want a system to exhibit. At a very high level, we define these design goals after analyzing our system requirements that we were given by our stakeholders. But if you read between those lines, you may ask a question, why did we say optimize versus must have? Do we not want to have all of those properties and behaviors for a system? If you recall, what we learned is that we cannot achieve all these design goals due to the various trade-offs, and we will cover this aspect in detail in our subsequent videos. For now, let's dive into how we can identify system design goals by answering the when and the how question. So, when do we define the system design goals? When we are going from the analysis process to building the system design goals must be identified. The overall design goals should be decided earlier upon in the system design process. If we don't define them early on and we introduce them or discover them later, this aspect can have a significant impact on a design. Depending on the design goal, we may have to go back and make small tweaks in the overall design, or in worst case, we may have to start again. This can extend the system design phase and cause a ripple effect in subsequent SDLC phases. Now, in order to identify the design goals, we follow a 3-step approach. First, the functional requirements. We work with our stakeholders to identify the functions that a system needs to perform. Non-functional requirements. Based on the functional requirements, we look deeper and start to define the non-functional requirements. We will learn about both the functional and the non-functional requirements a little bit later. And finally, understand the trade-offs. So once we have our first set of design goals, we work on refining them further. We need to understand how achieving one design goal may impact on achieving another design goal. For example, if our goal is to improve the quality of a system, we should have to put more time and effort in testing, which will increase the time to market. So it's important to understand that the design goals and the trade-offs that they come with. Finally, we pick and choose and focus on one or many design goals and de-scope or compromise on achieving certain other design goals. One of the questions that is often asked, do we define design goals for our overall system or do we do that for each subsystem? We want to define design goals for our overall system, and then for each subsystem, we can have the same design goals or variants or altogether different design goals depending upon the requirement for the subsystem. We can use the overall design goals for a system as a baseline, and then depending on the function and the requirements for the subsystem, we can add, remove, or override the expectations to optimize specifically for the subsystem. Over time, when we design a large number of systems, we eventually will be able to easily figure out what design goals suit best for a system. Initially, this process may seem a bit challenging, but trust me, over time, it will become relatively easy as we go. Now, let's look into functional requirements. A functional requirement is a specification of what the system should do. As discussed, we captured those requirements from our stakeholders. Now, let's go through some of the examples of functional requirement. Assume we have to build an e-commerce system. The system allows customers to place orders online. So some of the functional requirements may be as follows. The system must allow users to register and create an account. The system must authenticate the user before they can submit an order. The system must send an confirmation email whenever an order is placed. It's all about the features and functionality that a system should support. That's why they're called functional requirements. Please refer to the earlier video about functional model to learn more about functional requirements and how we can represent them with a use case diagram. Now let's look into non-functional requirements. On the other hand, we have these non-functional requirements. A non-functional requirement is a constraint on the operation of the system. As discussed, we capture these non-functional requirements also from our stakeholders. Let's take our functional requirements regarding the email that we have to send when the customer submits an order. The functional requirement states that we must send an email upon the order submission by the customer. It does not specify how or by when the email should be sent. But the non-functional requirement takes it further. It states, the system shall send the order confirmation email within 3 minutes. This adds a constraint on the functional requirement of sending the email notification as how fast this email has to be delivered. We could have other non-functional requirements in our e-commerce system such as the system shall be able to display 100K products within 3 seconds. The system has to prevent creation of duplicate orders in case the customer clicks the submit button twice. It's all about adding constraints, and that's why they're called as non-functional requirements. Now let's see what is the difference between functional and the non-functional requirement to understand them a little better. We will compare both of these on 3 different axes. The first being product. Functional requirements define what product should do, versus non-functional requirements help us answer how the product should do that instead. For example, functional requirement states send a push notification to the customer when the order is received, whereas the non-functional requirement states that we should notify the customer real time within 10 seconds. The second axis of comparison is documentation. When we write the functional specification, we write in this following format. The system must do requirement. Whereas when we define the non-functional specification, we write in this following format. The system shall be requirement. If you compare this format, there is only one difference, the must versus shall. Must implies that we need this function, that is, it is mandatory. But the shall implies that we want to optimize towards meeting or exceeding the expectation, but with the understanding that it may not be possible to fulfill it 100% in practicality. The third and the final axis is measurement. Since the functional requirements refer to a specific product functionality, it is easy to define, measure, and test these requirements. For example, functional requirement states that the customer must pay for the full order amount before the order can be shipped. During development, we can build various unit and integration tests to make sure that is the case. Separately, after deployment, we can run some automated checks on the created orders to make sure that the orders that were shipped were indeed charged with the full amount before they were shipped. Such requirements are easy to define, measure, and test it. However, these non-functional requirements, which are also known as quality requirements or quality attributes, can be more abstract. And these requirements impose constraints on the implementation of the functional requirements and are not easy to measure. For example, consider the following non-functional requirement. The system shall perform consistently, that is, the system should be reliable. How can we make sure that the application performs consistently? This qualitative aspect is not easy to measure. Let's take another example. The system shall provide seamless user experience. How can we measure seamless user experience? This seems a bit abstract and even subjective. We may have to rely on surveys and user feedback to get some signals, and this will require more manual intervention, and definitely it's not easy to measure objectively. I hope you got a fair understanding of the functional and non-functional requirements, and in the next video, we will continue on subsequent topics.